Yes, I always love to with my team break it down. We have a big milestone in our star, but then you break it down into sub milestones. And so what we're looking for as I see the development of quantum networking with QPUs is, first of all, that you can simulate it. So I'd look for publications, and I think Aliro is going to be part of some of these that actually simulated a more realistic multi-node QPU network based on entanglement. You show how the simulation runs, the requirements for the transducers, the requirements for the QPUs themselves, and you look at predict what the fidelity of 2-qubit gates would be across different processors. So simulation is really that important first major milestone. Then you want to, as I showed in a slide here, I think I can go back to it. Then you want to actually set up entanglement across nodes in the lab, actually show that you can do entanglement distribution and measure those. And Aliro is actually working on this already. Well, you want to then integrate the QPU, and a milestone would be to show that you have a QPU to transducer. So show that actually you can transduce from a qubit frequency into a photon frequency at the telco wavelength. That's going to be a key milestone. And what is the efficiency of that? Because you need to have likely over 90% fidelity of a 2-qubit gate at a distance to be viable, to actually use that 2 processors or 3 processors as a larger quantum computer. And then you start to do gates across the processors, you start to show the fidelity of those arrangements, and then you get to the final step of running an algorithm. It can be basic at first, but run circuits across multiple QPUs. Look at the fidelity. That's going to be the key metric of that computation. And then the big one is application. So then finding those killer apps for QPU networking, which will be the killer apps for quantum computing.